Hi guys, here we are, 5B. We're on page 9 in your book. So we're going to actually learn how to write equations of lines from a graph, how to write equation of lines from just given points, all kinds of different stuff that we're going to learn about lines in this particular Unit 5. So the first thing we're going to talk about on page 9 is not really the slope-intercept form of the equation of a line. We're going to do just a little bit more graphing on page 9, and then actually we get into this title of this equation on the next, this title of this section on the next page. So they're asking us to make a table of values and find the initial value and rate of change. So remember, rate of change is our slope. Our initial value in all three of these examples is going to be when the time is 0. So we've got three different functions down here, but they all have to do with time, and time is going to be the independent variable. So we're going to make a little t-chart, and in this case, the distance is a function of time. So time is our independent, distance is our dependent, and I generally almost always start at 0 because our initial value is when the time is 0. So that's going to be my starting spot. So when I plug in 0 for t, it cancels out that whole -2/3. So our distance is 5. The next point I'm going to pick is going to be something that's going to cancel with this 3 in the denominator. So I am going to pick 3. And when I multiply -2/3 times 3 over 1, I get -2 plus 5, and the distance becomes +3. Technically, all you need is 2 points to determine a line, but I always pick a third point because when I'm graphing it, I know I need to get a straight line. And if I've done any of this calculation wrong, I can still get a straight line with 2 points. But if I add the third point in there, then I'm pretty sure that my calculations are correct if my line is straight. So I'm going to pick 6 because, again, 3 goes into 6 nicely. So 3 goes into 6 twice. -2 times 2 is -4 plus 5 is 1. Did I do that right? -4 plus 5. Yeah, is +1. So we're going to come over here and we're going to graph it. We're going to talk about the initial distance. Again, this is when t is equal to 0, when you have not even started yet. How far have you gone? So the initial distance is 5, and this is in feet. And the rate of change we're going to actually get from our graph over here. So let's go graph our points. 0, 5, right there. 3, 3, 1, 2, 3, 1, 2, 3, and 6, 4, 5, 6, 1. So if I had a straight edge, I could draw a straight line through these, and I'd be satisfying myself that my points are correct. And now I want to look at the slope, the rate of change. And we're going to do it just visually from the graph. It's pretty easy. We know it's going to be negative because it starts high and falls, so I don't even have to worry about that. All I have to do now is get the rise over the run. So, ooh, that is such a fat pen. The rise over the run. So it's negative. How much do we rise up? And in this case, we can think of it as a fall from one point to the next. That's 2. And how much do we run from one point to the next? 1, 2, 3. So the slope or the rate of change is -2 over 3, and we always have to add the units back when we're dealing with a formula like this. So that is feet per minute. So for every 1 minute, -2/3 of a foot is the change. Let's look at the next one. We're talking about volume now. Again, a little t-chart. The volume is a function of the time. Volume is in cubic feet. Time in this case is in hours. It was minutes up there, hours now. But it doesn't matter. We're going to start when the time is 0, and the volume is 3. When the time is 1, 4, and 2, 5. Go over and plot. So 0, 3, 1, 4, 2, 5. And if you connect the dots, and you do a straight edge, you get a straight line. And we look at the initial volume. What is the volume when time is 0? Well, the volume is 3 cubic feet. The rate of change, the slope, we know it's going to be positive because this line starts low and rises. So we can write a little plus sign there. That just kind of reminds me that I've taken care of the sign of the slope. I know what it is. And when we look at the rise over the run, we rise up, run 1. Rise up, run 1. So 1 over 1, or just 1, is our slope. And when we add the units, it's 1 cubic feet per hour. Sometimes you see unit rates written with the word per. Sometimes you just see it with the fraction mark. Okay, here we go. Third example. Again, we're going to have time in seconds, and speed is the dependent variable. And when time is 0, the speed, is 4. Looks like the speed is always 4. Nothing happens to the speed. So as the time increases, the speed stays the same. Our initial speed is 4, and the units is miles per hour. The rate of change, let's go plot our points. So 0, 4, 1, 4, 2, 4, and you can see where this is going. This is a perfectly horizontal. If I could draw it. Sorry, that just drives me crazy that I can't do that better. Perfectly horizontal line, and the rate of change is rise over run, but we never rise up or fall. We stay the same. So this is 0 in the numerator, so it doesn't matter what our number is in the denominator. The rate of change is 0. And these units are kind of funny because you have to have these units, miles per hour per second. That sounds kind of weird. All right, let's move to the next page, and we're going to really start the meat of the matter for this slope-intercept form of a line. There's a lot of ways you can write an equation of a line, and there are 3 or 4 different formats that we're going to learn. The slope-intercept form is written in a very particular manner. Your y comes first. Y equals, then you have your slope, your m, in front of your x. It's the coefficient of x, and you have a constant called b on the back end. And no, b does not stand for back end. So again, m stands for slope. It's a weird word. It came from a French word. B is the y-intercept. When you think about intercepting something, you take a hold of it. An interception in football, you take a hold of the ball. An interception, an intercept in math is where the line crosses the y-axis. Where does it take hold of the y-axis? And we said m is the slope. So if you look at this picture looks kind of complicated, but it really isn't. It's showing you the slope, which is the rise over the run. It shows it in formula format between the 2 points. It also shows it graphically, just the rise over the run. You know it's positive because this line starts low and rises from left to right. And then it also shows you the B for the y-intercept. This guy right here is where this graph takes a hold of the y-axis, and we call it B. So when you're writing an equation of a line in slope-intercept form, you have a slope and you have a y-intercept. Let's do some. Okay, so now I've given you some examples. All of these have the same format. They've got y is equal to m, the slope, the coefficient in front of the variable x, and it's got a place where the graph intercepts the y-axis. So the slope is -3, or you could think of it as -3 over 1, the rise and the run, and it's negative. So we know automatically our line is going to be falling from left to right. The y-intercept is +5. That's where the graph is going to cross the y-axis, +5. Slope, 2/3, rise over run. Y-intercept, -7. This guy takes a hold of the y-axis at -7. 4 over 7 is the slope, y-intercept 1. And this guy is written backwards. We need to kind of think about him by putting the x in front. y-intercept form, the x comes first. So his slope is 2, his y-intercept is 5. We've got one more little set of examples down here. These have slopes and y-intercepts, but sometimes they don't show up exactly. So those of you that had me last year, we talked about the ghostly 1 a lot. This x has a coefficient. Yes, he does. It's 1. So your slope is 1, or 1 over 1, rise over run. And it's positive. The y-intercept is -3. Over here, yeah, the slope is -3/5, but I don't see a y-intercept. It's the ghostly 0 plus 0. He crosses the y-intercept at 0. On this one, there is a ghostly -1 and a ghostly 0 on the back end. So the slope is -1. Again, the y-intercept is 0. And this one is kind of funky looking, but if you try to write it in the form we're looking at, it's 0, y equals 0 x's plus 2. So your slope is 0 and your y-intercept is +2. These are sort of the exceptions, but you need to think of every line as having a slope and a y-intercept. Sometimes you need to write them in. Okay, thanks for listening.